What are the strangest yet the deadliest formations in space as we know it? Well, the answer to that question is indisputably a black hole. Black holes were first theorized when Einstein came up with the theory of general relativity, which explained all sorts of size and matter and geometrical shapes and the distribution of matter between them. But there was a huge hole missing in his theory, one that Carl Schwarzschild ended up filling in 1915 with his theory on black holes. Black holes were then theorized to be able to make ripples across space-time, and he found this to be a true thing. We know black holes are formed two ways, one of which is from the death of a star. These stars are roughly 8 to 10 times the mass of our sun. What they do is they end up burning out of all of their hydrogen fuel. They expand as they're looking for more and more to burn. And then when they finally exhausted all of their fuel, they collapse in on themselves and create a single finite point of infinite density. The second way a black hole is formed is through gas. Whether you believe it or not, gas, thousands upon thousands of light years across of just nothing but gas. It will slowly converge on a single point and eventually collapse. And instead of creating a star, they create a black hole due to how much density it has to withstand. Now, we do know smaller scale. Some stars can turn into a black hole, but most stars that are smaller than 8 to 10 times the mass of our sun end up turning into neutron stars, which are equally as scary, but they're nowhere near as dense as a black hole. Now, most of these neutron stars can merge with a black hole and give the same effect that a black hole would merge with itself, another black hole. But that being said, black holes can also be huge, galactic even. There's actually one of them in our center of our Milky Way called Sagittarius A. That would be called a supermassive black hole. Now, these supermassive black holes are also called a quasar due to how much mass it ejects on each pole that it has. Now, you're probably wondering, what does a black hole actually look like? Now, I can try and make a black hole. Now, this black hole has many key features about it. In the middle, you have the singularity, the infinite point of density, which sucks all life, all matter, all energy into the center of this black hole. And the only way they get to be with the singularity is to coming past the event horizon, which the event horizon is the black shadow you see around you. This black shadow, once you cross it, you can never return. Nothing gets out of the event horizon. Now, the one way you can get away from a black hole, especially coming that close to the event horizon, is being lucky enough to be spat out through the relativistic jets on either poles of a black hole. They only form when a black hole is feeding on matter or energy, and they spew hot red plasma from the north and the south pole. Now, relativistic jets are not exactly the only place hot plasma and energy are dispelled, but around the photon sphere of the black hole is right outside the event horizon. Now, we call it the photon sphere because red hot plasma is always making photons. And these photons believe that they are going in a straight path. In all reality, the black hole is warping their space-time and making them run laps infinitely around the black hole, never to go left, never to go right. The best place to be around a black hole is around the innermost stable orbit. Now, this innermost stable orbit is right outside of the black hole's photon sphere, and that's the safest place for matter to exist. Now, the entirety of this disk is called the accretion disk. The accretion disk is made of nothing but dust and gas and any junk you could think of in space. Relatively all natural, nothing man-made, but these accretion disks make it so easy for us to spot them because of how bright they are. I hope this gave you some clarity on what a black hole is, how it forms, and what the dangers are with black holes. Luckily for us, there are 100 million in our own galaxy alone. But in the same sentence, there isn't one for 26,000 light years away. We're relatively not in the path of a black hole's destruction, but our research is just beginning. Who knows what we could find?